Abrir agora a sessão, está bem, Mariana? Esperas uns segundos. Começa.
Hello, everyone. We are just going to wait a few seconds for the people to join in, and then we start the session. Thank you. So, good afternoon, everyone. My name is Mariana Avila. I am a project developer and a project manager at the Air Center. Today, in this Networking Friday session, we'll have a dedicated session to a project called New Space Portugal, which is funded by the Resilience and Recovery Plan of Portugal. And without further detail, I want to pass the word to the executive director of the Air Center, Miguel Miranda.
Good morning to all of you. Let's try to explain very quickly what is the goal of our work package within the New Space project. In principle, there will be new imagery acquired by the Atlantic Constellation very soon. The new satellites will give us better resolutions, in some cases better spectral content, and there is still the hope that some of them will give us a radar imagery. And so our goal was to understand what could be the advantage for a number of market segments that could be the result of this big investment that is made by Portugal and the cooperation with Spain, UK, and the other countries of the Atlantic that is being designed by the promoters of the Atlantic Constellation. And so we divided the market into what we call the carbon service market, because most of the Earth observation data can be used to track, for example, carbon sequestration. That is a very important goal within the carbonization that is decided by the European Union and by the world itself. Maritime transportation, because this is probably the most important from the financial point of view of the uses of the ocean. The climate change, because most of the hazards that are now facing, that societies must face every day, they have been emphasized by climate change, and so better data or better or lower revisit times can give us some advantage. The security and safety market that is connected with the previous one. Food security, because most of the new information can be used also to track the food security almost everywhere. And finally, more I would say, simple application, like the real estate or the energy markets, that are also important segments of our economies and that can gain from the new information and the new ways to process it. So it's not only the question of seeing what are the new data that will be available, what are the new approaches that can be developed to benefit from this data, and what is the advantage from the citizens' point of view, from the private sector point of view, from the governmental point of view, that we can have for the availability of the future Atlantic Constellation. So this is the goal of WP5.
Excellent. Thank you very much, Miguel. And now we'll start session one, which is called Services for Maritime Transportation and Energy Markets. And we'll start with a presentation from our colleague Andrea Giusti, that is a project developer, about the whale vessel collision risk assessment. Andrea, the floor is yours.
Okay. So I believe you can see my presentation.
Yes.
So thank you, Mariana. So so I am Andrea Giusti. A very pleasure to be here. I'm a project developer at the Atlantic International Research Center, where I work in the Space System and Application Group. Well, it's really very glad to be here, having the opportunity to present the following work. In this brief presentation, I will showcase as the main focus the detection of whales using AI in satellite imagery, which can support the whale vessel collision risk assessments. And of course, other applications related to marine protection and conservation. So as you may know, whales are not just iconic marine animals, but play also several fundamental roles. In fact, an healthy and robust population can regulate marine ecosystem functioning and also global climate regulation. For example, by cycling nutrients, whales stimulate phytoplankton growth, which is a major driver of carbon capture and ocean oxygen production. These ecological benefits translate then back to us, for example, from ecosystem services to nature-based tourism, like in the case of whale watching. A healthy whale population can support coastal economies and livelihoods, as in the case of the Azores Island. So in return, however, they don't receive sometimes equal treatment from our side, and are especially threatened by human activities, such as navigation, which often coincide with their habitats. Vessels are in fact a major growing pressure, both in terms of collisions, but also with regard to the noise. One proven mitigation that has been implemented is the speed reduction. Some initiatives, such as along the United States East Coast, set seasonal mandatory speed limits in specific areas to lower the risk of strike. But of course, like trade-offs are always behind the corner, and this is, of course, has a cost to commercial shipping of millions of dollars per year. To mention other initiatives, for example, the Blue Speed campaign is pushing for a 10% speed reduction in European waters, and the WWF Protecting Blue Corridors is another global collaborative initiative to map movements of whales and also pinpoint where mitigation measurement will eventually have a greater impact. So with such objectives in the front, it's hard not to think about the possible applications of space-based technologies to know when and where whales are actually present. So in the case of satellite technology, these represent, of course, a great potential, especially for very high resolution images, as the one that are going to be provided by the Atlantic Constellation. Satellite-based analysis is in fact proven to be able to support the reduction of whale vessel collision by providing near real-time whale detection warnings, support whale vessel collision risk assessments, for example, by conducting whale census, identifying the possible aggregation areas, and as well as hotspots, and support the optimization of speed reduction to minimize cost, but also can also help in other tasks such as the assessment of population and support the management of good practices in whale watching, for example, the distance between the vessel and the animals. So as happens in different technologies, also the use of very high resolution imagery to detect whale is a new and technically advanced and not yet standardized. So some trivial challenges are firstly related to the cost and licensing of the imagery. We can eventually be tackled by partnership and by data sharing agreement. Moreover, the archive data that we have sometimes is not acquired over the ocean, but is limited, and therefore new tasking is key to this, but has also an implication which has higher prices. So far, the detection is also being done under ideal condition, meaning so no clouds or no winds, while the detection results in an operational condition might have a higher degree of uncertainty due to the sea state, the turbidity of the water, or the cloud cover. Therefore, in the scope of the new Space Portugal project and accounting with synergies with other projects such as the Interreg Atlantic Whale Deal, we had the the goal of developing and validate an automated satellite-based artificial intelligence pipeline to detect whales and support marine protection, and by this trying to reduce the whale vessel collisions. So we tested and developed this on imagery provided by our partner Geosat, which has similar characteristic to the one that we acquired by the Atlantic Constellation. For now, our regions of interest were, for our test, the Azores Islands and the Canary Islands. So to reach our goal, we created a training data set that comprehend of 185 instances of whales captured in different hotspots, and also non-whale objects such as ship, cloud, whitecaps, and so on. To the base data set, we then applied random augmentation to increase the diversity of our training data so that we finally obtain 8 main classes with around thousands or more instances depending on the class. So with such data set, we trained a deep learning model for computer vision based on the Vision Transformers architecture. The choice of this model, it came from the fact that it shows excellent results in the Earth observation domain, especially when leveraging transfer learning and starting so with the initial model already pre-trained on larger data sets. So after several runs, test and sensitivity analysis for tuning the different parameters, we obtained good performance metrics with a good precision score for the weight class of around 93%. However, still we have some misclassification, especially for the case of whitecaps and clouds. Fine. So I will finally a bit showcase here the pipeline to detect the whales, and is composed of these main steps. So firstly, it loads the image and applies pre-processing. Then it classifies the images and detect whales. The third step is a supervised module that allows for the validation of the result and ensure higher accuracies. And finally, the results are aggregated and visualized in maps. In the first chunk of the pipeline, it loads automatically the image. In this case, a GeoSat-2 image that was acquired over the south coast of Pico Island in June 2022, and applies an efficient masking to land, so we avoid to classify parts of the image that is not our interest. The next automatic step in the pipeline, allow to prepare the data for the classification by dividing our entire image into manageable tiles. The pipeline allowed the Vision Transformer model and perform the classification. In this example, it classified around 40,000 tiles in around 5 minutes, which is a very efficient process considering that this is an area of around 15 by 15 kilometers. The visualizator allowed to zoom in our result and have a close look to the detection. Here we were able to detect successfully three different, in three tiles, some whales. For each of them, we can check here in the visualizator the degree of confidence associated to our detection. We can also check the same for other classes. In this case, we had a successful detection of the small ship. But also we can control eventually if we got some false positive detection, which is of course the case when you're dealing with these kind of tasks. So once classified, the pipeline allowed for the human in the loop validation for higher accuracy and continuous model improvement. Well, finally, we have the last step. So at the end, the data are aggregated for an easier visualization that allowed to the creation of occurrences map. Well, so to complement and support our work, we also conducted in parallel some validation and feasibility studies. In particular, we analyzed the revisit times and coverage of satellite constellations in the region for the feasibility and operational context. We also compiled a dataset of whale sightings for validation of satellite results and a list of cloud-free geosat imagery. For this, we consulted reference resources, including project partners, and establishing also some data sharing agreement with whale watching companies. So to conclude, this AI-based classification pipeline allowed the successful classification and detection of whales in very high resolution imagery as those acquired by the Atlantic Constellation. The tool is meant for the support of whale vessel collision risk assessments and other application for marine protection and conservation. Finally, this organized code can be incorporated into a central service, which is eventually accessible to operators and many others. Well, thank you. That was the showcase.
Thank you very much, Andrea. And now we will pass to Adriana Ferreira, our maritime applications developer, also at the Air Center, and she will show us the internal wave service. Thank you, Adriana.
Thank you, Mariana. Can you see my presentation?
Not yet.
Sorry.
No, we were seeing your presentation. Yes.
But I need to
Yes.
to present. Can you
Perfect.
see well now?
Perfect.
Yeah. Thank you. So I will present the internal wave service. Firstly, I need to explain what are ocean internal waves. Internal waves are waves that propagate inside the ocean between layers of water with different densities, not on the sea surface as we are used to see. This occurs because as we go deeper into the ocean, the water becomes denser. When the density changes sharply due to the salinity or the temperature, it creates a boundary between layers called the Picnoc line. When this interface is disturbed, typically by underwater topography, such as seamounts or continental shelf edges, internal waves are generated. The movement of internal waves generate orbital particle motions, which at the sea surface form slick bands that make them visible both to naked eye and in satellite data. The strongest type is called internal solitary waves and can reach altitudes of hundreds of meters, transport energy efficiently without dispersing, and generate strong currents often bigger than 2 meters per second. So why are they important? Internal solitary waves transport energy, they contribute to mixing, they transport nutrients, they help in climate regulation, so they have a connection with global ocean circulations. They also make coastal impacts and influence engineering and submarine operations. Here we have 3 images representing 3 key studies of internal solitary waves. The first one is a recent study about the importance of internal solitary waves in climate of Mark Artawil 2023. The image on the right, it's a study. It's about a study done by Osborne and Birch in 1970s, where they suggested that unexplained movements in oil platforms were caused by internal solitary waves. At the time, the idea was dismissed as speculative, but Osborne was removed from the project, but years later, satellite data confirmed that they were right, and nowadays we know that it is an important factor to these structures. The last image, the small on the right, it's about an Indonesian submarine that sank during a training exercise in 2021. Although the cause was never confirmed, some scientists suggest that large internal solitary waves, up to 100 meters in amplitude, observed in the area, may have contributed to the accident by affecting the submarine's stability and buoyancy. Here, we show some examples of internal solitary waves in optical images from Sentinel-2, Sentinel-3, and MODIS images. However, they can be very difficult to see because of atmospheric conditions and sun glint. The best way to observe these phenomena is with the SAR images. So the problem is that global observations of internal solitary waves remains challenging and has been restricted to a few hotspots. This was the most up-to-date map of internal waves that we were aware of. It was created using MODIS image from August 2002 until May 2004. Now, with Sentinel-1 data, since 2014 and ongoing, we can now build a current evolving map of internal solitary waves with improved coverage, resolution, and near real-time potential. So our main objective is create the first global near real-time service for the detection and monitoring of internal solitary waves. At the moment, we are using the wave mode images from Sentinel-1, which operates primarily over open oceans with VV polarization. It captures 20 kilometers by 20 kilometers vignettes at a resolution of 5 meters at a regular 100 kilometers intervals along the orbit. However, Sentinel-1 wave mode does not operate in coastal zones normally, where the satellite typically uses other modes. This is our current pipeline. Every day, the model processes all available Sentinel-1 wave mode images that are thousands per day, around 6,000 or between 6,000 and 8,000 per day. Images classified as negative are automatically discarded, while potential positives are currently reviewed by experts and labeled as inconclusive, confirmed positives, or confirmed negatives. The newly validated cases are continuously used to retrain and improve the model with the long-term goal of reaching full automation. Confirmed positives detections are published in this moment on an open access global map that we can access in this link. NVIDIA supported us in developing a robust machine learning model for this application. This is our validation platform for expert use. In this case, this image was predicted as positive by the machine learning model and then confirmed as positive by the expert. This is our current map of internal solitary waves that we have in this moment. At this stage, it includes approximately 1 year of global data and 5 years of data over the equatorial Pacific Ocean. The color scale represents the number of overlapping detections at each location. To the best of our knowledge, this is the most up-to-date and representative map of internal solitary waves in the open ocean worldwide. As we continue to process and integrate images back to 2014, the map will become significantly more complete and representative worldwide. In this moment, we can already identify examples of known hotspots like South China Sea, Mascarenhas Reach, Amazon Shelf, and Bay of Biscay. But we can also, we could also find new and unexpected regions like sectors of the Southern Ocean, Central and Eastern Equatorial Pacific, mainly around the 10 degrees north, and tropical Atlantic near West Africa. The presence of internal solitary waves in these regions is unexpected since the ocean is very deep and there are no bathymetric features or strong tides that could generate them. So it's important to understand why these internal solitary waves really exist in these regions. This is an example of persistent internal solitary wave activity near of Gulf Stream. And as we can see, even if the signature of the internal wave service is weak, like in this example of 22 July, the machine learning model can detect these waves. With the goal of improve this prototype, we build a community around this service. For that, we organized a workshop in April this year, where we put together some experts in internal solitary waves to improve this prototype. Today, we are supported by 23 institutions with which we are jointly defining the next steps to build a more robust global map of internal solitary waves with better temporal and spatial resolution. The upcoming satellite missions under the new Space Portugal can contribute significantly to this effort. So the next steps that we have defined for now, it's expand global internal solitary wave dataset with the Sentinel-1 wave mode until 2014 and ongoing, but also add the IW mode to have a better coverage near the coast. Also develop segmentation and AI methods for precise internal solitary wave characterization. Prepare for future missions like Roselle and the Harmony from ESA, but also New Space Portugal mission, if possible. Establish thematic working groups and collaborative publications, and revisit historical SAR data, for example, ENVISAT, before 2014 using AI. That's it. If you have any questions, you can email me or ask now. And you can also find more information in this link.
Thank you very much, Adriana. Now we will pass to the time to do some questions. I also wanted to highlight, I already put the link on the chat, but I wanted to highlight that your input will be essential in guiding the future of these services. So I will put the link again on the chat for the feedback survey. you can reply regarding the session 1 material, but also session 2 that will occur after our break. And you also have the option to reply either session 1 and session 2. So
There is
you-
a question for Andrea in the chat.
Yes, I will pass now to the questions. So the first one that I have is from Pedro Carmo, and Pedro is asking, during your presentation, this is for Andrea, during your presentation, you showed 8 classes your pipeline is trained to classify. In the whale class, you add a number in parentheses, but in the same slide, you add a different number of whale instances. Can you clarify what the number in parentheses refers to? This is for Andrea. I don't know if you
Yeah, I'm
want-
here. Was just trying to see the. So yeah, of course. Like so, the creation of the data set include like the definition of unique instances of the objects. But then, like, of course, this we applied some augmentation that maybe I mentioned very quickly that allowed to differentiate a bit the base data set, let's say. So in order not just to have one single centered whale object or ship object or whatever object, but having the same object seen from different perspectives. So that was it's normally like a type of let's say task that is done to accomplish like a larger data set, especially when you're dealing with a critical class that there are few instances available and so on.
Okay, Pedro says that makes complete sense. Thank you very much. And we also have a question from Mário Alberto Vieira, our panelist. And he says, I'd like to make a question to Andrea. First of all, very interesting presentation. Regarding the Pico Island case study, how do you validate that the result of the detection model is really a whale? Is there any other detection source to cross-check results? Thank you.
Yes. Yes, there are so resources to check. Of course, like is challenging. Imagine you have records of sightings that might be available on different platforms. I was listing in the presentation a few of them. OBIS CMAP is a large collection of sightings, not only of cetaceans, but also of different species, and allowed to let's say have coordinates, latitude and longitude of whatever species you want to see when it was observed in real life in nature. Of course, like the image is passing in a moment, eventually in the same day, but not in the same time. So it's challenging. For this case that I was showing, around Pico Island, there is a lot of data taken by whale watching companies that have protocol to report what they observe, and then they also share this data on different platforms. So in this case, we were kind of sure that was because of first the environmental conditions of that day. The sea was definitely without any waves or any white caps, so it was pretty flat. Was a high season for the whale watching in the region, and then we cross-checked with some data that were published by one of the whale watching company, say that they observed what we believe that whales were. They were like blue whales, and they were spotted for June 2022 around there. So that's why we are sure about it. And of course, it also there is a part which has a, how can I say, is the validator who is in this case was me, but not only me, like also other colleagues of mine, that by seeing a lot of images, then after a while you start developing, since you're sensitive and you can spot and be, let's say, sure with a good degree of certainty that what you see is a whale. It's not always the case. Sometimes you're not sure.
Thank you very much, Andrea. We have one more question from one of our colleagues, Natalia Ospina Alvarez. To Adriana, I know that research related to internal waves is an ongoing topic, but are you aware of any studies that have looked at the impact of internal waves on the economy?
I think that everything that is related with the infrastructures is economic related, as well as renewable energies, aquaculture, and the quality of water. Internal waves can influence all these issues.
May I? We had a meeting with Petrobras in Brazil because Petrobras has lots of offshore stations, and internal waves on offshore stations, they are very important. Second point, we have been recently in Luanda discussing with our friends from the Fisheries Institute, and something I was not clearly aware is that internal waves are relevant for even for fishing availability. So this is something that is not only a curiosity for crazy researchers, is also a very important topic from the economic point of view, as Ospina points very well.
Thank you very much. I don't know if there are any more questions. Okay, if not, I can, Miguel, I don't know if you want to say anything or, okay.
Next one.
So, okay, so I will ask you again. We are reaching the end of session 1. We'll have a 10-minute break before starting the session 2. You could take the chance to use these 10 minutes of a break to please reply to the survey. So right now it's 1:37. So we'll be back at 1:50. Okay? Well, see you in a bit. Thank you very much. Okay, hello again. In the meantime, while I was closing the session, we had another question on the Q&A. And this question is from Bolarinwa Balaogun, and it's to Andrea. What do you think are the limitations of the current satellite sensor you are using for the whale? And what sensor will you consider better?
Yes, so hi Bola, thank you for the question. Limitations are always a bit linked to the resolutions of the satellite. Especially spatial resolution is of course key, especially when you want to detect something which is already hard to see. But also I could say like the spectral resolution. Having a satellite in the blue band, which has a coastal blue band, like allowing for a, let's say, a bit deeper view into the water column. That would be of great help for detecting whales, especially when you have limited contrast between the animal and the surrounding background. And I would consider better, yes, probably a satellite that has these characteristics. But in the case that now of the Atlantic Constellation, like what is good, I think, unless of limitations that are always there. I think the great advantage is that, as I was saying in the presentation, oftentimes the satellites companies are not acquiring data over the ocean. So a great advantage is that this planned constellation has as a main focus the ocean, and so we would have a great amount of data to then perform our task. Yes, hope I replied.
Thank you, Andrea. So now we'll start our session 2, and it's the session for the services for energy infrastructures, from planning to operations. And we will start with a presentation about the Atlantic Constellation for remote infrastructures monitoring, and it will be given by Inês Miguel. Inês, the floor is yours. Thank you.
Yes, thank you very much. So let me just share my screen. Okay. The presentation mode. Sorry for the delay. Okay. Here. Okay. Can you see my screen correctly?
Yes, we are seeing your screen.
Yep. Okay, thank you very much. So welcome everyone, and thank you very much for being here. My name is Inês Miguel. I am a business development manager at Geosat, and today I'll be talking to you about the Atlantic Constellation for remote infrastructure monitoring. So first of all, just a couple of notes of who is Geosat. So we are a fully European satellite operator, and we are one of the 2 optical VHR satellite owners and operators in Europe. We provide, or better, we have end-to-end control of the operations of our satellites. So this means we are able to acquire the imagery and to deliver it to you all in one process. And we have a global coverage with that, with the support of our 24/7 team, will ensure that we can respond to the requests of our customers all over the world. We are also able to do near real-time acquisition and delivery, and deliver to you solutions that are tailored to your needs. So this basically goes as this slide shows. So we are able to provide VHR satellite imagery, so both archive from the last years and new tasking for more updated images. We can provide the satellite as a service, so the customer can buy the orbit and use it for their needs. And we also provide integrated data services, making use and taking advantage of the data that is acquired with our satellites. Just to give you an idea of our current capabilities also, so right now we have GeoSat-1, that is a satellite that has a very wide swath, so a 600 kilometer swath, and GeoSat-2, that is our very high resolution satellite that was also mentioned during this session already, that allows us to have imagery with a resolution of around 75 centimeters, with the possibility to go up to 40 centimeters with super resolution, so with an AI-based algorithm. And for the Atlantic Constellation, where we expect for the next couple of years, on the Portuguese component, we have GeoSat-3, that it's our VHR light precursor satellite that was launched this year, so in January 25. And along with this satellite, we will have 2 more satellites in the next couple of years with this submetric capability and with other bands and all. And together with these ones, we will have the 5 VHR satellites that will allow for the increase of the resolution that the constellation will be able to provide, along with the increase of the capacity of revisits. So, and now focusing more then on the services for the remote infrastructure monitoring, I will go through a couple of uses that we foresee and that we are working on in this area, and also then how the Atlantic Constellation can help with and can be used for this purpose. So when we are talking about infrastructures, basically the satellite images can be present in all the steps of the construction of these infrastructures, meaning we can use it for the site selection, for the logistics planning of the construction, for the monitoring of the construction itself, and also then on the operations. So in this first example, we can see a land use land cover map. That is a map that allows us to differentiate the different types of areas that we have in a specific zone. So we can distinguish between the trees, the water, crops, urban areas, etc. And it allows us to know the characteristics of the ground, the topography, and also risk areas that need to be identified, for example, for extreme floods, etc. We can also detect in more extreme environments, for example, in the desert, the dune movements. So this allows us to study the movement of the dunes where we want to put, for example, the wind farm, so that it will not interfere with the operation later on. And we can also monitor the changes around the operational wind farms that we have already in place to make sure that the infrastructure is safe. And another type of service that we can have for to help on the site selection and also on the logistics plan is the road detection and the road characteristics that we can determine that will allow us to have an idea of the existing infrastructure that is in the area that we are studying. So if there are already any roads, if not, for the transportation of the materials to the place. And on this, we can do this road detection to understand what is the status of the road, so if it's paved or if it's unpaved, and also to determine the width and the angles of each road. This will allow us to have, for example, a point A and a point B, to have the constraints of the vehicle that will do this transportation, because as we know, for example, in wind farms, the pieces that need to be transported are not so usual. So normally they are really big or really different. And so with this, we can apply some constraints and understand what is the best path to take from one point to the other one. Then the imagery also allows us to track the construction progress of the infrastructure. In this example, we are seeing the progress of a solar plant. And in this one, we can see the same place with a couple of months different, where you can see that on the left we have the already the platforms prepared, and on the right one we can see that we have already some materials on the platform, so it means that the construction is starting to take place and it's ongoing. Then we can also spot deviations between the approved plan and the on-site reality. So we can have like a layer with the plan that the project manager has of how the wind farm was supposed to be and how it is in reality with the updated imagery. And so you can understand what are the non-conformities, if there is any risk, if not, and if there are any measures that need to be taken. Then we can also do the platform detection and to understand what is the status of each one. So we can see if it is already a cemented platform, if we have a platform under construction, or if it's finalized, which allows us to have this kind of maps where you can understand the status of each platform of the wind farm, and with that understand the whole picture, so the status of the whole wind farm. And also another important use of the imagery is to understand, to support with the logistics planning. So as I said, for example, with the roads, with the road detection, and also understanding what are the materials that are already in place. So we can help in the materials transportation, in understanding the number of components that are already on site, and also to assess their condition. This will allow us to save money and time by reducing the on-site inspections, and also to keep the plans updated without the needs of other people. And as you can see in this image, we were able to check the types of materials that were already inside and to identify, in this case, 15 blades and 39 tower pieces that were already ready to be installed. But I have been focusing here in the wind farms and in the solar plants, but of course this kind of images and analysis can be applied to all types of infrastructures, such as power lines, pipelines, transport networks, etc. And in addition to what I've said, and also focusing a little bit on the operations, but also in the other phases, we can also do it is possible also to do the monitoring of the vegetation, so to understand if it's not a danger to the infrastructure that we are monitoring, to plan and audit without the field visits, to detect unauthorized constructions around our infrastructure, and also to maintain regular imaging to ensure that you have baseline data in case an event takes place. So in case you have a flood, or if you have a fire, you can understand how the infrastructure was before and how it is affected after this kind of events. Now focusing a little bit on the offshore part, the satellite images can also help in the build out of the offshore project, so similar to what I have been talking about, but also to ensure the safety and the security of this kind of infrastructure. So we can detect vessels, ice caps, or any unusual offshore activity. In this example, we can see that we were able to detect, in this case along the coast, the different boats, and we are able to understand what are the types of boats that are around, for example, our infrastructure. So the size, the velocity of them. And we can also monitor coastline changes. So we can take 2 images, do the coastline, and understand how it has evolved in order to support also the operations. And last but not least, we can also the satellite images are also used with an environmental impact where we can do this kind of chlorophyll maps and understand the algal blooms in order to allow for the detection of risks for the infrastructures and also to study the impact of the infrastructure itself on the local marine ecosystems, ensuring the compliance with the environmental regulations. So the potential key benefits of this constellation, and keeping in mind that we are still testing these kind of applications and always looking for other purposes. We believe that the potential key benefits of the Atlantic constellation will be divided in these new characteristics that we are working on. So with the capability of making a video where we will be able to identify dynamic events. The tracking agility that will allow us to better cover the areas that do not follow the conventional linear path of the satellite. So, for example, a road or a railway, where you can better do the tracking of that kind of infrastructures. And the new bands, for example, the SWIR band, where we will be able to have more impact on the emissions measurements and land water management. And of course, on the other side, with more satellites, there will be more revisits that will allow for the faster coverage of larger areas and also to increase the revisit of the sites of the infrastructure where the infrastructures are, especially as we are talking here today, the remote ones, that will allow for a better control of the changes that are happening on site without the need to go there. And that's it. Thank you very much.
Thank you for your presentation, Inês. Very good. Now we will pass to the presentation from Mário Alberto Vieira from WAVEC about offshore wind from above, monitoring floating farms with satellite data. Mário, whenever you...
Yes. Can you see my screen?
Yes, we do, but not in presenter view.
Yeah.
Okay.
Okay. Okay. Good afternoon, everyone. First of all, I would like to thank our center for organizing this session and Geosat for inviting us to participate. It's been very interesting to acknowledge the developments of these institutions on the topic. Regarding WAVEC, for those who don't know, we work on marine renewables. We support new projects. We provide consultancy and participate in innovation projects regarding offshore wind, wave energy. And specifically, we have been now recently trying to grasp the benefits of using satellite data to monitor floating farms or the operation of floating farms. So why should we, let me just try to remove this menu from here. So why should we use satellite monitoring for floating offshore wind? So to start, farms are usually installed in remote locations and turbines are scattered assets. And furthermore, new farms have the tendency to be installed further from the coast. So the cost to inspect all these turbines one by one is very, very high. Offshore operations are very expensive. And so this amounts to a great quantity of money. Also, there is always the risk of undetected failures, which could cause stoppage in the operation of the turbine or even a catastrophic failure. And for this, we obviously have in situ monitoring systems, but satellite could contribute. Also, in the open ocean, there is a lack of surveillance tools. You can have cameras, but still satellite provides a better means to make it. Also, and as Inês from Geosat has stated already, we can also use this data, this satellite data, to monitor environmental parameters. So, for the case of offshore wind, satellite provides redundant monitoring, which will reduce risk by providing a broad tree view, system-wide surveillance of farms. So what is the opportunity size? Offshore wind has been gaining traction in many countries, particularly in Europe and also China. But the floating counterpart is not yet very explored. Okay. For 2050, we expect approximately 1,748 gigawatts, from which approximately 15% will be floating. And when we implement these floating offshore farms far from coast, we will need advanced techniques to monitor them. From these 260 gigawatts expected by 2050, approximately 10 gigawatts are expected for Portugal, as you most probably know. So there is definitely the potential to generate complementarity between different sources of data to reduce the risk of operating these farms. And reducing the risk is not only an operational matter, it's also it will also influence insurance costs, the possibility to extend the life of farms, etc. So this is really, really important to try to understand and to monitor these infrastructure in different dimensions. So one of the main aspects, benefits that we see with including remote sensing into this monitoring is to articulate data from different sources, okay, and see the farm in a forest view instead of only looking at a tree. Also, we can complement this monitoring with machine learning and other AI algorithms to try to retrieve useful information. And the data that we can use currently, that WAVEC is using, is essentially optical image satellites, notably from the Sentinel constellation, also from the Geosat constellation. And one of our main speeches is that current state-of-art monitoring systems, in situ monitoring systems, monitor the turbines independently as a standalone device. And sometimes Captain Stewart strategies are used, which means that we are not monitoring all the turbines, but just 1 in 5, 1 in 10, which is not ideal. So satellite data can complement these SCADA systems with data that was not available previously, and so this also brings the issue where we defend that we should be looking at the forest, not just to the tree, and this is the broad view that satellite data can provide us. As I mentioned, currently we are using data from Geosat and Sentinel, but several satellite image data options exist. Higher resolution imagery offers much greater detail, obviously, at a higher cost, but tends to have lower availability. On the left, I show you a linearly interpolated image from Sentinel of a wind float Atlantic platform, and in the bottom, it's the same platform but taken from a Geosat image. So other presentations have highlighted the potential for the Atlantic Constellation, and we are at WAVEC really looking forward into it, since we believe it will contribute to improving the reliability and frequency of satellite data available for monitoring offshore renewable energy projects in the Atlantic. So this is definitely something we are looking forward to. So in practice at WAVEC, we are combining satellite imagery with machine learning, and other physical models that we have in-house to detect patterns in platform motion, turbine orientation, and environmental variability, amongst others, but this is the ones I'll be talking to today. So first of all, as I tried to highlight in the past slides, Sentinel data is free. It has a very decent revisiting period, but the resolution is very, very low. And usually we can linearly interpolate the image. However, many times this is not yet sufficient. So at WIVEC, we developed a super resolution routine that uses a machine learning comparison with geosat imagery that we have of the wind float Atlantic to try to improve these Sentinel images. And the main goal here is to get these super resolved images to have more features for detection through segmentation or other classification algorithms. It's really important that we have these features clearly identified in the image. Other model we are developing is the model for platform detection using a segmentation model. And here in the left, you can see an example of two platforms that we are including in our model for detection. We have a true mask, and then we have a predicted mask. Actually, this is for the same image, which is not ideal, but we have also tested the model for new images which were not part of the training set. Okay, with this model, we were able of clustering data based on metocean conditions, and we were capable of classifying the position of the wind float turbines, the absolute position of the wind float turbines based on wind and wave metocean conditions. And actually, we concluded, and this was more or less expected, but we now have a quantification to this, that the position of the platform is mainly dictated by the wind direction and intensity. Furthermore, we are developing a binary classification model for turbine status. Essentially, we are trying to understand if the turbine is either in operation or stopped. And for this, we feed the model with wind production data from NCOE, wave data and wind data from Copernicus Marine Service, and also the Sentinel images, which were super resolved by the super resolution model that I presented before. And with this model, we can see these two graphs, these two charts on the right. In the middle, we have the position, the absolute positions of the platforms when the turbine is on, and we can see the absolute positions of the platforms when the turbine is off. So we can see there are clear differences. So there is a lot of intelligence to get from this data. Okay, we can also use these images to try to measure, at least detect hydrodynamic and aerodynamic effects. From this image, we can see the wake effect of the platform on the ocean current. We can also see a vessel. This vessel is currently doing maintenance operations in turbine number 3. And from this image, you can also tell that turbines 1 and 3 are stopped and turbine 2 is operating. This is some of the sensitivity that Andrea mentioned in the first half of our event, that we will get this sensitivity as we process these images even manually. But what I wanted to show you is that we can also measure, detect, and classify wake effects of the turbine. So in this specific image, if we look further down or further south, we will see that the wake effect spans for approximately 6 kilometers, which is a relevant value and can be relevant for environmental impact assessments. And also another comment, not only for environmental reasons, but also when we have bigger farms, these wake effects will influence the downward turbines, okay, and it will affect the efficiency of energy extraction. So this is definitely an issue that needs to be taken into consideration for bigger farms. Also, and from the models that I presented earlier, and particularly the platform positioning, we were capable of measuring supposedly mooring failure in the wind float Atlantic. I hope there is no one from Ocean Winds in the audience. If it is, I'm sorry. It's just a supposition, but all data points out towards the fact that there was a failure on turbine 3 on December last year, and this was clearly identified both by the visual inspection of the images on the left, and it is also reflected on the right as we have a clear outlier on the absolute position of turbine 3. Okay, I don't want, this has been already addressed by Nish from Geosat. We are also evaluating the use of satellite image to evaluate environmental parameters on the SADU estuary. And this is important because WAVEC is involved in a PRR project with Etermar, and Etermar is an offshore platform constructor. And we want to evaluate whether construction operations will cause environmental impacts, particularly in the prairies of the SADU estuary, but also other parameters that we are considering. For example, we will use satellite images to follow these construction activities, which are supposed to start in December, and we will be acquiring Geosat images for this. Very well. So takeaways that I want to reflect from today. I think I've shown that satellite data can enhance or complement traditional monitoring. And by complementing this imagery with machine learning, we can unlock the detection of operational status and anomalies in the farm. So broad surveillance will mean risk reduction, lower costs in maintenance, higher production, etc., etc. Obviously, WaveX developments are yet embryonic, and we expect that as more satellite data becomes accessible and better algorithms are employed, better benefits for the industry will be achieved. And in particular, WaveX is finalizing the minimum viable product of our digital satellite monitoring platform, which focuses particularly on the surveillance of floating offshore wind farms by measuring operational parameters such as platform position, status detection, and others. And also, we will try to retrieve environmental monitoring insights and cross these environmental parameters with operational parameters as well. So because these are developments we are currently doing, we are seeking for partners, collaborators, and potential clients for these developments. So if you want to participate in any way, please talk with me. And yeah, this is the end of my presentation. Thank you very much for your attention.
Excellent, Mário. Thank you very much. Now let's pass to the question and answers and to the feedback survey. I already posted again the link on the chat, and we have a question from Paula Kellett to Inês and/or Mário. How easily available is such data, especially in near real time, to possible users from the energy sector? Where would the data from these satellites be made available, and are there any restrictions in its use? I don't know if Inês wants to start. Yes.
Yeah, I can go. So, for example, for the Geosat-2 data, it is commercially available. So we have the possibility to have NRT, the NRT service, so the new real-time service for acquisition and for delivery. And as I said, we also have the 24/7 support team. So if the satellite goes by the area that you are looking for, we can take the imagery. There is some data, I think, that is also available through the Copernicus services, but I think it is more on the archive data. So on the real time, it will be more on the commercial side, and you can contact us with your needs, and we will be able to support you.
Thank you, Inês. Mário?
Yes, I can complement a bit to what Ines said. In case of WAVEC, we are using mostly Copernicus data from Sentinel and Geosat data as well. And the data by itself is available either on Copernicus platform or provided by Geosat as soon as it is taken. There are some limitations on image retrieval, such as cloud coverage and other parameters, such as availability of tasking. But at least from our perspective, when we need the image, it is not immediate, but we can have an image in a fairly short amount of time. And also, this is why I believe that the Atlantic Constellation is so important, because it will reduce the revisit periods, and hopefully it will standardize the access of these images to everyone. On the confidentiality, I think there was a mention to confidentiality, or whether there were restrictions to the use of data. Well, to my knowledge, Geosat is a better institution to respond to that question. But from the energy infrastructure perspective, there is no restrictions, and it's important for utilities, for any company that manages a big electricity production farm, to understand this. Anyone can access this data, so this can pose also a risk, but it is also an advantage. So everyone and the asset owners should make use of it for their own benefit.
Yeah, on the restrictions on Geosat, well, in this case on Geosat images themselves. So normally we try to understand what is the specific use. So if it's not a standard one, I don't know what would be here the case for the question. But normally the license that we provide to the client, we try to accommodate what is that they want. So we have a license to the image, and then we can talk about the fact of any products that result from the image, or etc., that we can understand how we can adapt the license to those needs.
Okay, I have a question on the chat regarding the survey. From Pedro Carmo, it is supposed to happen because we want to know what organizations are replying to the survey. So yes, it's supposed to happen like that. Do we have any more questions? Feel free to raise hands, to write on the chat. We have a few minutes. So, Paula Kellett replied, and she said, just to clarify, I am not actually from an energy company, but from the European board, European Marine Boards. But it's useful for us to know, as we are engaged in relevant projects with such companies. Let's give some more minutes. Do we have any more questions? Feel free to do questions, to give feedback. Okay. If we don't have any more questions, I will end this event, this Networking Friday webinar that was dedicated to the new Space Portugal project. I want to thank you all for your participation, for being here with us, and to give us an opportunity to show us our services that we are developing on Work Package 5. We'll have the session 3 of this series on the 28th of November. Further details will be shared on our social media. So let's keep in touch. Thank you very much again, and have a nice weekend.